Hi all, welcome to another session on Python for data engineers. This is a continuation of pandas module. So before we dive deep into the topics for today, let me have a quick revision of what is pandas, what we have learned so far. So we know pandas is a package useful for data analysis and manipulation, and we have seen a number of methods. So we can import the pandas module like this, import pandas, and we are giving an alias so that we can reference PD instead of pandas every time we need it. Some important methods we have seen is we can read a CSV file using this method. Um, there are several parameters that we can specify as well. So when you read a file, it will be read into a data frame. The data structure is called data frame. It looks like a table like this, and then we can do different transformations on this data. So some parameters, some most commonly used parameters of these methods: if there is no header, you can specify header equals none. Otherwise, the first row is interpreted as header to avoid that default behavior. Then if you want to provide header names, you can either provide it separately as df.columns method or property. It's not a method, it's a property. Or you can specify while reading the file by specifying header as none and specify the names of the columns in the names parameter. So either use columns property or names parameter in the read CSV method. Similarly, we can read Excel file using the read Excel format like method. We can also specify the sheet name, etc. Additional parameters are there. This is just the bare basics. Some other properties are like shape, gives you the number of rows and columns. Then, yeah. Some important other methods or transformations we have done is one is renaming the columns. We can use the rename method and specify a dictionary, a column mapping dictionary. And if you want this renaming to be permanent, you need to specify in place equals true. So the column mapping dictionary will have on the left side, or the key will be the existing column name and the value will be the new column name. So here I'm just renaming 3 columns, but it is not practical to manually rename everything. So we can use the property df.columns to get all the column names. And then whenever there is a space, I want the space to be replaced with an underscore. So we can use something like this, df.columns, and then we are applying a string method. So we use str.replace, and then what we want to replace, a space, and how you want to replace it with an underscore. So df.columns will give you this, and then for every value in it we need to apply a string method. That's why we use .str.replace, and then we are assigning this output to the df.columns. You already know df.columns is one way to assign column names to your data frame. So we are directly assigning the transformed output of this code here so that the data frame will have the proper column names. Then another important feature is converting dates. For example, here we have a timestamp, but all the time values are zeros. So you want to convert this timestamp into a date. We can do something like this, to date time. Then we can filter for rows using something like this, whatever condition we want to apply. So if we want to filter from this data frame, only those have a complete status. Then if you want to access a specific column within a data frame, you can use this syntax, df, and then within square brackets the column name. So in this way we access the column order status, and then we are looking for the value complete. So whenever the value is complete is true, so for this it will be false, for this it will be true. So only when it is true it will return those rows. So row 3 will be returned. It should have been df complete. So let me quickly do this demo for you. So first we need to import, and then so I have applied date conversion, converting the eliminating the time values. Now if I just do this, let me show you. For every, so it will return a series. So every row, what is the value of the order status? And if I do something like this, what I get is another series. So first row order status is not complete. That's why it's returning false. This is false. Third row, the order status is complete. That is why it's returning true. So when you do something like this, you are getting a series of true or false values. So when you pass this series into the data frame, only those for which the value is true will be returned. So if you do df complete, all the values returned are complete values, the orders that are complete. Okay, now we have learned about some data enrichment, like adding an extra column. What we can do is, so this is the data frame we have added, then you can add an extra column like this. You need to specify the new column name and whatever should be the value. Here we are assigning a static value, the file name. So if you want to do a calculation based on 2 columns and apply that, you can do that. So just giving you an introduction about what is possible. We looked a little bit about aggregations and grouping as well, the group by method, and then what is the column based on which we want to group, and then we can specify some methods like this. So after grouping by order status, we want to get the count of order ID for each order status. So cancelled, we have this many orders, closed, we have this many orders, like that. And we also learned the definition of pandas series. In this session, we are going to be talking about primarily data cleaning. So more on data cleaning. In order to do that, I have created some data frames. Intentionally, I have added some corrupt data in there so that I can demonstrate the data cleaning process. So whatever is covered in this are actual scenarios that I have encountered while working on a similar project. So the objective is we will be getting files from our vendors via SFTP. So we have already covered how to get the files from different SFTP locations. So after downloading the files from the SFTP location, we need to validate the data and then load it into a Snowflake table. So we are now in the step of validating the data. So we have loaded the first file, no issues, everything is fine. And then as we move on to the next vendor, we encounter different issues. So that's what we are going to see. So for the sake of simplicity, I have saved these files as CSV files, because if I save them as Excel files, when I open it, sometimes Excel will automatically correct some of the intentionally made errors. So to make our lives easy, the purpose of this is to demonstrate how to deal with different errors. So for the sake of simplicity, I have saved them as CSV files, but the actual files in the project are Excel files. So First, let's load the files. So we know what is the method to load the file. Um, read CSV. So the files I have stored here inside the data folder. Vendor 1 is an actual Excel file. Vendor 2, 3, 4, all these files are the ones I'm going to use for the demo. So let me copy something from here. Yeah, let's take this one. Okay, so the file name is going to be vendor 2. I know it does have a header, so I'm removing this, and then let me print this. Okay, read CSV. ABD, it's not ABD, contract hire. Okay, perfect. So I have read the file. Okay, from the first glance it looks okay to me. Let me have a review. Okay, I don't see any issues. Let's do some further digging. So what I'll do is, let me check the data type. So before loading into a Snowflake table, I wanted to make sure that we have the proper data type for all the columns. That is one check that we do. So what we can do is we can use this property to get the data type. Plan code is an integer. Okay. Client name, division, address. These are all object. That's fine. String. Zip code is a number. Okay. Hiring manager, these are all objects. Let's see. Invoice date is interpreted as an object. I want to make sure that it is a date, so that is something we can do. Employee ID is int, that's good. Then hours and charge dollars should be number types. Yeah, it is float, so that's good. So only thing I'm going to do is I'm going to convert the invoice date. So we already know how to do the date conversion. So PD Q date time, and what is the column? The column name is invoice date. So this is the column that I want to convert. Let me just run this. It's giving me an error. So invalid date specified. So there is invalid date. So the default behavior is when you use the toDateTime function, if there are values that doesn't comply with the standard date, it will throw an error. So we can suppress this error by using errors equals chorus. So in the last session, we have learned about three different options. You can ignore, or you can throw an error, or you can use error equals chorus. If you use ignore, then invalid date values, when you try to insert into database, there you will get an issue. So that is why we are trying to solve it now. So now if I use this, I'm getting, there is no exception. So that's good. So let me instead of the existing DF invoice, what I'll do is I'll replace that with this converted values. Before that, there is a function called isNA. Let me talk a little bit about it. So detecting missing values. So if there are any missing values, we can use this isNA function. Let me show you df dot isNA. There is also isNull. They are both kind of same. So it's showing whether it's true or false. So what I'm going to do is, so if I check now, there is no null values in any of the columns. This is one basic check that we do when we are doing the exploratory data analysis. So there is no null values here. Okay, now I'm going to do this date conversion step. And now the invoice date has been updated. Now let me do this again. So we can see invoice date, there are 20 um, null values. That's because 20 date values were corrupted date values, incorrect date values. So if you want to see what were those incorrect date values, let me load the data frame again. And then what I'll do is, okay, that's going to be more complicated. Let's ignore that for now. So there are values that were like not compliant with um, a standard date format. Let me see whether I can notice anything in here. These values looks okay to me. Yeah. Let me do something like this. Um, Invoice date. Now it's updated. Let me, okay. Okay. So here we can see whenever there is a null value for the invoice date, these are the values. Row 28. Let me try to open this file maybe. So row 28, if you check 2024 1210. Find what is the issue. Let's see. 9935. Is it 9935? Okay, this row here. Oh, okay. This is what is mentioned as a. Oh no. 9935. This is an erroneous. Afternoon shift. Okay, after Thames DB1. Thames DB1. Okay, see 32/13/2023. So that is not an actual date value. There is no month called 13. There is no date 32. So this value cannot be converted into a date. So that is why we were getting that error, and we suppressed that error by using errors equal squares, and then instead of that we replaced it with a not a time, a native value, so that yeah, instead of having a wrong date we have a null value. So when we load this data into database we won't be having any issues. So this is one way to deal with issues in the data. We can convert that into a null value, but that may not be always the case. There are some other options available as well. Yeah, this is how we can filter for rows with missing values. If you want to find those without a missing value, we can use this particular method. I've just put some notes here. Okay. So next what we want to do is dealing with null values. So when there are null values, how we can deal with it? That is fill NA. So first we learned about is NA to check whether there is a null value. Now when we know that there is a null value, we can use fill NA to deal with that. So replace missing values with a specified value. There are multiple ways we can deal with it. We can specify a specific value, or we can specify a method like for forward fill, backward fill, or even values from another column or row. So there are so many different ways. So in my case, replacing these date values with a null was not an option, because this data, once it is inserted into Snowflake table, it's going to be used in the reports, and those reports are based on the invoice date. So I cannot have null values. So if, say, the business end users tell you that, okay, this is the data for the month of February. So if you have a null value for invoice date, then you can replace it with the last date of that particular month. In case of April, that's going to be April 30th, something like that. So depending on the business requirement. So this is your requirement. You cannot replace it with null, but you have this requirement. So what you can do is, first you will convert the date, and you will identify those values that doesn't confirm with the date format, and then we will use the fill NA method to replace. So let's see how to do that. What you can do is, we are concerned about the invoice date. Sorry. So we will pick the values of invoice date, and then we need to apply the fill NA method. So fill NA, and then for now I'm statically coding it, but you can programmatically determine what is the last day of that month, and then you can use that as well. For simplicity, I'm just gonna use April is 30 days, right? So 2024. So whatever value, whatever constant value that you want to be filled it with, that you can use. So now it's printing it. We cannot see it, but one way to check it is, currently if you do null count, there are 20 values with null values. So now what I'm going to do is, the existing value of the invoice date column, I'm going to replace it with this new value, and then I'm going to check the count of null values again. Now you can see there is no null values, and you can even check df dot so I'm just printing those three. I know that row 28 had an issue before, right? So 9935. So this is how you can query. You can find specific rows. So starting from row 27 to 29, the ending index is not inclusive, the starting index is inclusive. So starting from index 27 up to 29, 30 will not be included. That's how I can print specific rows. So I can see 9935, earlier it was a null value, now it's replaced with the value I have provided, which is 20250430. So this is one way to fill the null values. There are other ways. Let me quickly show you some more ways as well. For that, what I'll do is, I have another corrupted file. Let me load that one. So this one has no other issues. So let me get the code for reading the file. So suppose you have resolved this issue. Now you are thinking that, okay, it's all good, I have done the cleaning, and then you try to load another vendor. Okay, so you try to load another vendor. So this is vendor 3, and when you print, looks okay so far. So whenever I print, I also do the D types to get a better understanding. So let's see what are the issues with this. Okay, I cannot find any issues. Let's do the, okay, there is an invalid date. Okay, so there are more issues with date values. So let me try to do the conversion. So how we did the conversion is like this. Before that, df dot is na sum. To get some summary, I see pay code has 25 null values. Invoice date, there is no null values. I see more null values in hours and charge dollars as well. Okay, good. So what we can do is, let me show you how to deal with null values in this pay code, hours and charge dollars. That is a good way to demonstrate some more fill NA methods. Okay. So I want to display only those rows where pay code is null. So we can see that these values have pay code null. Now let me see what is pay code. Pay code is something like this. So I check with my business users. I tell them that okay, we have null values for this pay code, and we also have null values for hours and charge dollars as well. Hours and charge dollars. So these are numeric values. This is like a alphanumeric value. So there are a few other methods to fill the null values. One is, where is the documentation? Um, we have mean, median, mode. We can use these functions. So for numeric values, what we can do is, let me copy it here. So there are null values in the hours column. So if you select only the hours column and if you apply mean function, you can get the mean value. So whenever there is a null value, you can replace that with the mean value for that particular column. Or you can do the median value. So what you will do is df of hours fill NA, and then instead of providing a static value, earlier we have provided specific date value as the fill NA value. Here instead of that, we are calculating the mean of that column and using that as the constant value. Here we are calculating the median of that column and using that as the constant value. Or we can even do mode. So I'll talk about mode a little later. So hours equals this, and okay, df of charge dollars, I'll replace it with the result of this. Now if I do df is na sum, I can see hours and charge dollars, the null values has been replaced. So how we have replaced it? For hours with the mean value, for charge dollars with the median value. So it's a constant value. Now pay code is a alphanumeric value. So we cannot calculate mean of this, where is pay code? Mean or median of these values. Mean is like average. We cannot calculate average. That's why another option is mode. Mode is the value that appears the most number of times. So with mode, let me show you how the output will be. With mean and median, you will get a single value as output. But if you do mode, it's, oh, sorry. if you try to calculate the mode, so for the pay code column, if you try to calculate the mode, you're getting something like this. This is not same as this. Let's check the type of this. It is a series. So the reason is because with mean and median, there is a single value. But with mode, what if there is a tie? If there is more than one value that appears. So they, say for example, there are two values that appear 5 times. So that is the maximum value. And in such cases, all those values, if there is a tie, all those values that appear the maximum number of times. Say for example, um, let me show you something. df pay code, there is a function called unique. So these are the unique values. Say this one appears 20 times, this one appears 5, this one appears 2, this one appears 3, this one appears 20 times. So there is a tie. These two values appear 20 times. So they both will be returned by the mode function. So in our case, there is no tie. That's why it was returning only one value, but still it's a series. So in such case, we just need to get the first value. That is why I'm going to use this index. In this way, I can get the mode value. So again, the same drill. I'm going to use the mode value to replace the existing pay code. Okay, fill. Now let me try the isNA method again. Now all the null values has been handled. So why I demonstrated this is, it doesn't mean that you should always use mean or median or mode. You should check with the end user when there are data quality issues and see what the business needs. This demonstration is just to show you that these are the various methods that are available out there in order to replace the null values. But in my actual project, I didn't use any of this. We had to reject when there is a invoice date value missing because we needed all that values. Okay, so that is that. Now that we have handled hours and charge dollars, let's also deal with the date. So we already know how to do. Let me type it just to give you some practice. So we are dealing with invoice date, and what we need to do is we are going to use pandas to date time method. We are passing the values of invoice date. If there is any error, first let me try to run it. There is error, so that means there are invalid dates. So if there is errors, then I want to use the queries so that it will be converted into NAT. So I'm going to replace the existing value of invoice date with the new values, the converted values. And then I'm going to do is NA sum so that I can get a count. Okay, there's quite a number of values. Invoice date, 75 rows have invoice date as null. So it is more corrupted. So again, we go back to the business user and tell them that there is more corrupted date value. Then they tell us that, say for example, if they give you something like okay, up to 10% of the values, if there are data quality issues, we are fine with it. But if more than 10% values have issues, we don't want to accept that data. So they ask us to implement such a data quality validation rule. So let me show you how to do that. So they have provided you the threshold is 10%. So I'll declare that in a variable so that if they come up and reduce or increase the threshold, I can easily change it. So I have the threshold value, and then what I can do is there is a method called len of df. So there are total number of rows 500. Out of this, if more than 10% is erroneous, we don't want to accept it. So I'll store this as total rows, and then what I need to do is I want to find the count of erroneous rows. So erroneous rows are in the df invoice. So is na sum. So if I just do this, just for a particular column, I'll, instead of a series like this, when I specify a column and use is na, here I'm using is na on the entire data frame. Here I specify a column and specify the is na and get the sum of it. So I'll get the total number of rows that has null values. So these are invalid count. And now I want to find the percentage. So invalid percentage equals invalid count divided by total rows. And I want to convert that into percentage, so multiply by 100. So let me show you the invalid percentage. Okay, total rows. Okay, 15%. So it is above our threshold. So now we can implement like a if condition. If invalid percentage greater than our threshold, then we can do something like raise some error, value error, data quality failed. Ideally, you will be sending email to notify, because we don't want this to go unnoticed. So if we have like errors that are above the threshold value, we can send an email. I'll cover in another module how to send email from Python program. So for now, I'm just throwing an error. If there is no issues, then you can say something like, oops, print data quality. I'm just putting something quickly. Okay, so in our case, data quality failed. So this is something we can do. So let me quickly summarize what we have seen so far in terms of data quality checking. So first thing what we have done is reading our data and then checking the data types. And when we see that invoice date is not in a proper data type, we try to convert it, and then we check for null values. So when you convert invalid date into date time, you will get those values replaced as null values. So we learned how to replace null values. One method is specify a constant value. So for date values we have provided, so fill na method can be used for replacing the null values. One way is specifying a constant value, either a statically provided constant value or a calculated constant value. In this case we have used calculated constant values, calculating the mean of that column, we are calculating the median of that column. In here we are calculating the mode and getting the first value of the mode. There are some more methods that you can explore further. I have put it in the notes here. Forward fill, so that means filling the using the last known valid value or next valid value, depending on the previous row, whatever value was there in the previous row or whatever value was in the next row, instead of the null value we will replace that with that particular value. So that is another, sometimes that makes sense, especially with time series data. I think with our date value, if it is sorted, this may work as well. So there are different ways we can handle the null values. And then another method is having some data quality check threshold and if our data quality exceeds that threshold, data quality issues exceeds that threshold, we can reject that data set. So that's what we have seen so far. And now let's talk about some string methods. Do I have the methods? Okay. So let's look at some more corrupted data. I have another file. Let me load it. Okay, so this one is called 4. So let me load and show you. So when we have a quick look, we may not always notice, but I can show you quickly because here we have some issues. Charge dollars, it has a dollar sign. So we want to load this into a numeric column in Snowflake. So this cannot be loaded into a numeric column. And then there are some hyphen is you cannot load into a numeric column, that is considered as a character. So such kind of issues when you get manually um, so Excel file is something that is prepared manually, so it is common to get these kind of issues. So let's see how to deal with this particular issue. So again, first things first, we check the data types. So obviously we can see these two columns. Now we don't have a numeric type, so that's something we need to address here. And let me also do the check of null values. So for now we don't have any null values. Okay, that's good. Now let's move on to how to deal with this dollar sign. So for dollar sign is present in the charged dollars column. So normally when they have something like this, there is also a possibility that for big values like 1,234,500.50, something like that, when they, though it is a number, if it contains dollar and commas like this, it can be treated as a string, and we cannot do numeric calculation on such values. So along with dollar, if there is any commas, we want to remove that as well. So what we can do is, let me select that particular column. By now I hope you know how to select one single column from our data frame, df charge dollars. Let me print it. So it's giving me all the charge dollars values. Now I want to apply some string manipulation methods. So first I need to use as type str to, sorry, I don't have to use quotes, to make sure that it's converted into string so that I can apply some string method. So some string methods before applying, in the beginning itself I have mentioned to apply some string method we can use dot str and then use the method. So we are going to replace dollar with just some empty string. So dollar, there is a thing with dollar, a caveat. It could be interpreted as an regular expression. So to prevent that, we can use regular expression equals false to prevent it being interpreted as a beginning of a regular expression. So let me print this. So now you can see the dollar sign has been removed. So just to be safe, I can chain multiple methods. I will also add the method to remove any commas. So again, I can use comma to be replaced with just null. Okay, so we know how to clean this data. Now I will replace whatever is there in the charge dollars with this new value. Okay, now let me print. Okay, so this column is now clean. Now I still have another issue. I want to get rid of this hyphen. So for that, what we can do is, again, something similar. The column is hours, right? Hours. So I have all these hour values here, and then I want to replace. You can even use str, but let me try without that. And then pandas has a constant pd.na. Let me try that. So whenever there is a hyphen, it's replaced with an na, so that you won't have any issues while converting it into a numeric type.